dear viewers. Today we are going to see the some important. This video covers the some important terms and the relay operations. So that is the basic relay, overcurrent relay, direction and non-direction relay, and different types of relay. These topics we are going to see on these video sessions. That is in the electromagnetic relay operation already we are seeing. So over current relay and direction relay. Before entering to this topic, some important terms we are get awareness about these basic points. So this is the pickup current. What is mean by the pickup current? So already we are see that is the basic thing in this section. So all electromagnetic relay already we are seen the basic thing. Suppose if you have some electromagnetic operations, we are going to pass the current. So already we are well known. So we are going to pass that the supply. So that is the supply. Here we are going to provide if it is possible one switch is used. One switch is used to yes. So here that is the one of the switch is used. So here and another one thing we are assumed as that that is the any plunger or any other thing which is we have going to be attracted of that the system. If it is that is the ion piece, suppose this is that the ion piece which may be going to attracted and deflected, depends upon that the operations. So here that is the pick up current. So that is the pickup current. So the how much level of the current which is required to pull or some mechanism will be act as a push. So here that is the pull or push this magnetic element from its the position. Suppose this is the distance. Assume that is this is the distance which is pulled by this electromagnetic relay, that we need some, that is x amount of flux, which means psi of x. This psi of x flux produced by the voltage of v of x. So we want to know the x amount of quantity. So whenever the that is if you are going to fix the over voltage or over current, suppose the over current, that current rating is 5 amps. So the 5 amps is flowing. So simply this is the 5 amps. So due to some other reason this is overload, and then it may be going to increase. So it may be going to overload and then increase. So due to this action, for this action, that is the x value is increased. So whenever the current which can be is greater than the 5 amps, during that time the flux produced by that the coil psi of x, which can be sufficient to attract this ion piece. Okay, so this is the pickup value. So once again I repeated, the amount of flux produced by the relay which is able to pick the ion pieces, which is this is the yeah, it's a armature. It is nothing but the armature, right? So it's a pull or push of the armature. So that point will be considered as the pickup point. Okay, sometimes so this pickup point which may be vary depends upon that our requirement. Suppose depends upon the different current rating, we are change this the value, we are change this value. So that operation is some different operation. Suppose I am also going to wound as like this, right? So number of windings I am also wound this electromagnet. and I'm also going to tap on this session and this session and this session, finally this. So we have going to put the tap 1 2 and 3 and 4. So this is the common point. Again I am also going to take as that the point for that different point. Okay, different point. So here that is as usual the armature which is available is here for some other purpose we have going to be used. That is the whenever the positive and negative supply which is given to that the system. So this system which can be uh, as for connecting this overall, right? So this is the point. So it depends upon the change of this point, the flux produced psi of that is x, which can be changes the number of turns wounded in the coil. So simply I am saying if the number of turns is changes, then flux, that is n is changes. Again similarly it can be changes the psi of x. If psi of x is changes, then the pickup value, that is pickup value of the relay which is also going to change. So this is the one way of obtaining the different setting value. So how we are going to setting, this is the plug setting multiplying operation or a current setting multiplier, plug setting multiplier or current setting. So here we are going to see, so what we are going to 50, 75, 100, 125, 150, 175 and 200 what's here the earlier. So this is nothing but the different turns. These are all the different turns tappings we are going to take in here. This is known as the current setting usually achieved by the tappings. Okay, the pickup current which is, please see, this is the pickup current is equal to rated secondary current of the CT and current setting. What is that? The current setting. So pickup current, what is the pickup current? Rated secondary current. So suppose if you are used the that is the 100 amps to 10 amps, 100 amps to 10 amps. So there's a rated secondary current. Rated secondary current is a 10 amps. So what is its setting? I'm also going to put that the 100. So 100 into 10, that is the 1000 amps rating we are going to be get. So that is the secondary CT option, that is the peak value we are going to fix as per that is our requirement. Okay, so this is the point. Next one is plug setting multiplier, that is the plug setting multiplier PSM, which is the normally the fault current in the relay coil divided by pickup current. So how we are going to get the pickup current? Pickup current is equal to rated secondary current. Rated secondary current of the CT. What is this 1010? That is the 10 into current setting. What is the current setting? Here we are going to connect it. That is the point. Again that is the rated secondary current and current ratio. So here one example we are going to consider, that is the 400. This is the 400 for 5 current transformer we have used up to that is 150 percentage of overloading, right? So with the primary of fault current is 2.4k, which means 2400 amps, plug setting multiplier which is calculated, the pickup value is equal to what is the rated secondary current, that is we are going to obtain, that is the thing we have going to 5. So that is the 5 is 5 into 1.5, that is the what is the 1.5, because the current transformer, the current and the 150 set at 150 percentage. So we are going to set this is that is 7.5 amps. What is this? This is the pickup value. So one here is nothing but a 150 percentage. This is the 150 percentage. So due to this presence of this, so we are going to set this value for that the 1.5 here. Again that is we are obtain 7.5 amps. Fault current in the relay coil 2400, which is given here, into 5 divided by 4000 into 30 amps. The PSM setting value which is the 4. PSM value, that is flux setting multiplier, that is 30 divided by 7.5 is a PSM value is 4. Similarly, we are going to find what is the PSM value, that is a flux setting multiplier. Okay, so this is the point. So by using this technique, the relay which can be used in the from lower level to higher level. Okay, higher level, from lower point current picking value to higher point K picking value. Okay, so the next, the overcurrent protection scheme, we are going to see the another more operations. So time grader, one is the time grader, next one is the current grader, next one is combination of this time and current grader. So first of all, we are going to think about that is what is mean by the that is the current grader. Suppose if it is that the overload current which is obtained here, overload current is obtained here, if the relay, assume already relay which is run so many turns is there, so many turns, we are going to taken the tappings from the relay coil. Okay, so this is the point. So this is one point, this is the another point, again this is the another point we are going to taken. So this is the basic thing for consideration. How much level, please see, that is the time grader, next one is the current grader. Here we are going to consider the current grader. So suppose if it is, that is the we want to trip the relay, in the long position, in the different position. This is the radial systems. So we are getting that the higher values. Okay, so one is the time grader, another one is that the current grader. Please, we have going to let him know for the operations how it can be defined, right? So this is 1%, this is 1%. Suppose I am also going to trip in 80%, I am also going to trip in for the 60%, I am also going to trip in the 50%. What is the maximum point? So I am also fixed at the rate of 100 amps. The 80 amps the relay will be started. Here that is the 60 amps the relay will be start to pick the value. Again that is the 50 amps the relay start to pick. So the pickup time will be changes depends upon the magnitude of the current. Once again I am repeated, the pickup value of the current relay which can be changes depends upon the magnitude of the time. It is very important. The next one is the time graded. Time grade means, so here that is this is nothing but the radial system. This is nothing but a radial system. So if the fault is occurring here, again this relay is first tripping for 0.5 second. So this relay is not tripping due to failure or some other reason. Again relay B will be tripped. So this is the first point. This is the second backup protection, the first backup protection. This is the second backup protection. This is the primary protection. Again 0.5 second we are waited for 1 second. Again we are waited for the 1.5 second. So this type of tripping operations which is called as time graded overcurrent protections. That is the time grader. Simply we are going to consider as the time grader, which means we are suppose if the relay is a 80 amps is a pickup value, the 80 amps is pickup value is getting by this relay 3 to 1, and relay 1 is get and then waiting for 0.5 seconds, it may be going to trip. If the relay is not tripping, again this relay 2 which can be waited for the 1 second, again the 80 amps is continuous, the relay which can be tripped. So again, that is 1.5 amps, 1.5 seconds, it may be going to waited after reaching on its the maximum value. So this is the operation of the time graded operation. Next one important thing is that uh, the combined operation of that, the time graded and the what I am saying. So that is that the another one thing is current grader. So this is the percentage, please see. So this is that the percentage. Assume for explanation purpose this is a 60%. So this is that the 70%. So I am also going to put some rating for explanation purpose. So this is 80%. So if it is the current which may be operate the operation of the air relay, it can be reaches the 80% of the maximum current. What is the rated tripping? What is the picking value? Pickup current. Pickup current. So pickup current. So it may be going to reaches on its that is the 80 percentage of the rated. Again, it may be going to delay for some time. For what time we are going to take as that the delay. So this is the delay operations. So this is that the so this is that the another one delay operations which may be accumulator after reaching on its value, again waiting for the 1.5 seconds. So this is after reaching value, again that is 1 second it may be waited. So this is after reaching the value, again it may be waited for the 1 second, that is 0.5 seconds, which means that is 80% plus 1.5 seconds. After that period, the entire process only the relay may be tripping. So this process, assume that is a 70% of maximum, again 1 second. After that process only the relay may be tripping. So this point, that is the 60%, again plus at the time waiting for 0.5 second, the relay may be in trip. So this is the entire operation of that time graded, current graded and combination. So this video which covers the important term, that is the pickup current, current setting, how the current setting is varied depends upon that the relay system we have going to taken as the tapping and the explanations here we are seeing. So the next one thing is we are seeing that the what is the basic calculation of the plug setting multiplier. So the next one is time graded operation and that is the current graded operation, right? Okay.